Hello, YouTube, and welcome back. Here we are, Chapter 2, Section 4, Transformations. Okay, so let's see what happens if we let y equal f of x. What happens if we add 1 or subtract 1 from each y value? What happens, right? So this is I guess this is a translation. So, for example, let's say I take a mother function y equals f of x equals x squared, and I want to know what happens if I add 1 to it, subtract 1 from it, that kind of thing, right? So right now, I'm just going to graph the function by itself. And let's evaluate that. So right now we're just graphing f of, oops, I got to do a show, sorry. Where's my plot? Show plot. Get rid of that. I need a show plot. There you go. Boom. Alrighty, and there is y equals x squared. Okay, or f of x is x squared. So what happens if we add 1 or subtract 1 from that? All right, so let's do that, comma, f of x plus 1. All right, so the original graph is the, oh gosh, what is this, cyan, this bluish shade, right? All right, so the next colored graph, what is it, magenta, I guess? No, it's green, is what happens when you add 1 to this function. Now, this may not be just an aspect ratio, a square aspect ratio, but you get the idea. It's a vertical shift, right? So if we add 1 to all the y values, it goes up 1. Let's see, what if we subtract f of x minus 2, let's say? Let's graph that. All right, so that would be I guess that's magenta. So the original curve is the bluish curve. And if you subtract 2 from all the y values, it shifts, vertical shift down. Okay, so that's good to know. All right, so now I'm going to get rid of this show so it doesn't interfere with, it won't interfere with my other plots. So there we go. Number 2, what happens if we add or subtract from the x values, right? So f of x plus 1, f of x minus 2, that kind of thing, right? All right, so let's make our mother function y equals f of x equals x cubed, and let's plot f of x. And again, I'm just going to graph f of x itself, and then we'll add 1 or subtract 2, whatever it is, from the x values. So evaluate. All right, whoops, I did it again. Remember, we need a show command for anything that you want to show up, any output that you want to show up. If there's anything after that line, even another show, it won't graph this plot, right? Okay, so here's the cubic, as you know. Now this one I made an f min of -5 and an f max of +5 and a y min of -10 and y max of +10, so it won't go flying off the screen when it gets really big. Okay, that way you get a good feel for the shape of the curve. Okay, so now if we add or subtract from the x value, well, hopefully this is a review. Let's see, when you add 1 to the hx value, let's see, I guess that's the green curve. Look what happens. It shifted everything 1 to the left. So think of in the bluish curve, I guess it's, what is that, cyan? It goes through 0, 0. But what does the green curve go through? It doesn't go through 0, 0. It goes through -1, 0. So if we take every single point, let's say, oh boy, let's see, 1, 1 on the blue curve. This is not a square window. 1, 1 on the blue curve would now be at 0, 1 on the green curve. So now that becomes a y-intercept. So everything shifts 1 to the right, 1 to the left if you add 1. What if you subtract, I don't know, something? How about f of x minus 2, let's say. All right, now I think it gives you a magenta curve for the third one. There it is. And so again, you think of it like as if you could grab it with your mouse at 0, 0, the blue curve, and shift it once to the left, 1 unit to the left for every single point on the blue curve. It becomes a green curve. That's f of x plus 1 compared to f of x is the blue curve. But f of x minus 2 shifts to the right. Everything, instead of going through 0, 0, goes through 2, 0, and so forth. All righty, very good. And instead of going through -2, -8, it goes through 0, -8, for example. See the y-intercept of the magenta curve? All right, so that's a good demonstration of what happens when you add or subtract from the x values. That's number 2, or add, subtract from the y values. F of x is a y value. And number 1. Okay, let me turn off that show for now. And let's see what happens when you multiply or divide the y values by something. All right, so here's my mother function is the absolute value function. And let's just graph it. And then we're going to multiply by 2 or divide by 3 and see what happens. So right now, let's just see what f of x is. You know what absolute value looks like, right? Now, this will default to an x min of -1 and an x max of +1. Not necessarily a square window, but here we go again. I need to show. It's been a long summer. Hello. Okay, show. Let's graph that. Now that's the absolute value function, which looks like a v. There it is. And again, it's not the square window, but that's okay. All right, so what happens if we divide all the y values by 2 or multiply all the y values by 3 or what have you? Okay, so here we go. So, comma. What if I do f of x, take all those y values, f of x is y value, and divide them all by 2? What happens? All right, so the second curve, remember, is the green curve. So the slope is less steep, right, because the y values are smaller for each given x value. So in other words, the blue or cyan curve goes through 1, 1, but the green curve goes through 1, 1/2, 1,5. So that's when you divide the y values by an integer greater than 1, like we divided by 2, you have a vertical shrink. All right, what if I say multiply by something, like multiply by 3? So let's say comma f of x, whoops, lowercase x, that's case sensitive, times 3. What do you expect to happen? All right, well, let's find out. All right, so now the magenta curve is steeper, has a steeper slope. Instead of going through the point 1, 1 on the blue curve or the cyan curve, it goes through 1, 2, 1, 3, because I multiply by 3. So that's a vertical stretch. We call that a vertical stretch. All right, and you get the idea. Good. I think that shows what happens when you multiply by a integer greater than 1 or divide by an integer greater than 1. What happens if you do that to the y values or the f of x values? Okay, next transformation. What if we multiply or divide the x values themselves by something? All right, let's keep the mother function being absolute value function. And let's just graph. How about we graph the absolute value function f of x and then f of 2x, see what happens. And again, I need to show here. Alrighty, so again, we're going to have, what happened to my show? There it is. Again, the blue curve, which is really cyan, is absolute value. And then I multiplied each x value by 2. So instead of going through 1, 1, it goes through 1, 2. Why? Because 2 times 1 is 2. So it's like it's graphing f of 2. So what it's doing is it's taking points at bigger x values and plotting them sooner. So I'm going to call that a horizontal shrink. Okay, it's the green curve is steeper because it's shrinking horizontally. It's getting closer and closer to the y value, y-axis. And of course, you have an even function with y-axis symmetry. Alrighty, and what if we take that same function, f of, how about x divided by 3? So what happens if we multiply the x value by an integer greater than 1? That's a horizontal shrink. It looks like a vertical stretch, What if we divide by the x values by an integer greater than 1? Well, that would be a horizontal stretch, because think about it. To get f of the original f of 1, you'd have to plug in 3. Interesting. All right, so let's see what that looks like. And so it's stretched out. So when we plug in 1, we're really doing 1/3, right? So you have to go all the way to x equals 3 to get f of the function value to be 1 again. So that's going to be a horizontal stretch. That's why it's less steep. But it also looks like a vertical shrink, so it's similar. Okay. All righty, so let's turn off the show here. And let's see what happens here now. So based on that, you should be able to graph transformations, multiple transformations. Like here the mother function is y equals x squared, right? All right, so look, let's just see what's going on here. Let's do a show on this. And you can even do this by hand on paper, right? Notice what I call a mother function is what this thing is based on. If you know how to graph y equals x squared or f of x equals x squared, then you can do f of x plus 3 is shifting 3 to the left, And then minus 5 would be shifting 5 down like that, right? So you can do this in increments, in steps on paper. If you want to do this, by hand, you don't even need a calculator or graph or whatever. And please excuse my printer. All right, so let's print that. Let's graph that. So here's y equals x squared, right? So if you want to know what y equals x plus 3 squared looks like, isn't that shifted 3 to the left? Let's just confirm that. So you could do that by hand on paper. Just draw another graph on paper and compare it to the original graph. That's why I call it the original graph, the mother function. And it did shift 3 to the left. In other words, instead of going through a turning point of 0, 0, it's a turning point of negative 3, 0. And then the last step was, what happens if you subtract 5 from that? Well, that's going to be a vertical shift 5 units down, as you know. But let's confirm that. Yep. And then we get, well, again, this is not a square window, but this is trying to graph a turning point at negative 3, negative 5. Okay. There you go. Good. So let's turn that off, that plot. And let's see what else we can do here. All right, so here's another one. What happens if you graph 3 over x minus 2 plus 1? Well, that presupposes that you know what 1 over x looks like. Remember, that was a hyperbola that doesn't hit either axis, where the axes are asymptotes, right? So let's put another, there you go. So the idea here is to do this incrementally again. So let's just show what 1 over x looks like. And as you know, like we said, it's a hyperbola where the axes, the x and y axes, are asymptotes. There you go. Okay. Alrighty. And then again, I restricted the y min, y max, so it wouldn't get crazy because there's some vertical asymptotes and stuff going on here. All right. So what happens if you subtract 2 from the x value? Well, it's going to shift 2 to the right. So instead of having a vertical asymptote at x equals 0, it's at x equals 2. Don't forget, what it's trying, that blue vertical line there is really an artifact. It's not really part of the graph. It's trying to connect the lowest point that it plotted with the highest point that it's plotting. The lowest point that it's plotting before x equals 2, and to the highest point it's plotting after x equals 2. So that's, just ignore that part. It's not really like doing you a favor and graphing the vertical asymptote either. That's just an error. So ignore the vertical line, but it shifted 2 to the right. Okay. And then what else did we want to do? Well, we wanted to add 1 to that. So isn't that going to shift up 1 unit? Okay, so instead of having a horizontal asymptote of y equals 0, now it's at y equals 1. There you go, perfect. And then what about the 3? Well, that's like multiplying the y values by 3. It's just going to make a steeper vertical stretch, which is going to be hard to see here because we have a vertical asymptote anyway, so it doesn't really look that much different. It still has the same horizontal and vertical asymptotes. It's just bigger y values. Okay, so there you go. Perfect. Very nice. So there's all your transformations. So you can use transformations to graph complicated functions by hand. That's the gist of this, tonight's homework. All right, and one more like that. How about the square root function? Okay. All right, so if we graph just the square root function, what happens if we graph negative x? Okay, so square root of negative x, what does that look like? Well, let's compare it to just square root of x. Oh. All right, let's make that a show. Well, I don't need a show because it's the last command. All right, so here's a square root function. And as you know, that's what it looks like. It's having trouble graphing for negative x, so that's what that warning is there. Just don't worry about that. All right, so now what happens if we graph f of negative x? Well, I think we discussed this in the last video, that that's a reflection across the y-axis. Let's see. Because when you plug in 2, you're really graphing f of negative 2 and so forth. And there it is. Good. All right, what else do we want to do with this? We want to add 1 to the x values. Well, you know what that does. That's going to shift 1 to the left. right? Instead of negative x, it's going to be negative x, 1 minus x, or negative x plus 1. Okay, let's do that. If we add one, to shift one to the left. I'm sorry, one to the left, one to the right. There you go. And now we don't have all these errors because I already had that figured out in graphing only from -4 to 1. And then one more thing, add 2 to that. Well, it's going to shift up 2. So instead of going through 1 comma 0, it's going to go through 1 comma 2. And that's hard to see there, but just, if I could, how can we make that graph? Yeah, it's undefined for y is less than 2, so I can't really make that connect. But unless I graph something else there, like y equals x. But that's the idea. So it starts at 1 comma 2, and then it goes up and to the left. There you go. So you can actually figure out these graphs by hand without any kind of calculator or computer, but there you go.